Differentiation, lecture 1. Now, what is differentiation? Differentiation is method used to compute the rate of change of a function fx with respect to its input x. This rate of change is known as the derivative of f with respect to x. Now, normally your question, that is the function f, is defined with y. So we can say derivative of y in respect to x, which means when we differentiate y is the equation of line or equation of curve. When we differentiate y, we should be getting dy upon dx. That means derivative of y with respect of x. So that is a clear definition of differentiation, which says that method used to compute the rate of change with respect, you should know that it is the derivative of f with respect to the x. Now, derivatives with respect to x is dy upon dx. It can always have what? Derivative with respect to r will be d upon dr. That means that it can be the equation of y, it can be equation of a. So if it is equation of y, so it should be dy upon dr. Similarly, the derivative with respect to t can be used as well. So it should be d upon dt. Then derivative with respect to theta can be there as well. This would be d upon d theta. Now, before moving further, what is the requirement of this topic? Major thing is to understand the requirement of topic. First thing first, when your y is differentiated, you get dy upon dx. When y is differentiated, we get dy upon dx. Same way, if dy upon dx is differentiated, we get d2y upon dx square. That means this is your double differentiation. Double differentiation from where? Y to dy upon dx, dy upon dx to d2y upon dx square. Now, what are these values that will be taken out? What is this y? What is this dy upon dx? Or what is this d2y upon dx square? That is important to understand. That is the reason I'm not discussing the rules of differentiation yet, but I'm discussing that what you need to do in the differentiation or what you'll be asked to do in the differentiation. This y is basically your equation of line, or this is your equation of curve. These things, your y can be two things. Either it can be equation of the line or it can be equation of the curve. Similarly, this dy upon dx is what I say to make it easy. Dy upon dx is basically equation of gradient. Dy upon dx is the equation of the gradient for the point on curve. For the point on the curve. Then, what is this d2y upon dx square? This basically tells me, or I would say, equation of nature. This is the equation of nature. Now, what is equation of nature? Equation of nature basically tells me that if d2y upon dx square is greater than 0, then the curve is minimum. If d2y upon dx square is greater than 0, that means that the curve is minimum. Whereas if d2y upon dx square is less than 0, then the curve is maximum. That means that the curve is maximum. So moving further, knowing the fact that when we differentiate y, we get dy upon dx, that dy upon dx is basically equation of the gradient. Then we differentiate dy upon dx, we get d2y upon dx square. What is most important thing here is to understand why there is a need to differentiate. Why there is a need to differentiate. Now, normally, at any question or anywhere for the gradient, we have straight line. And for straight line to find out gradient, we have formula that is y2 minus y1 upon x2 minus x1. But if we are given x and y, and there is a curve, this curve does not represent gradient, or the curve will not have gradient, to the point that each point of the curve will have separate gradient, and that gradient will basically be for what? That gradient will basically be for its tangent. That means each tangent will have its separate gradient. Now that tangent is represented by values of x. That means each tangent will have different values of x, making sure that each gradient is different on the given curve. Because each point will have different gradient. Because each point will have what? Different gradient. So that means, why do we differentiate? To have gradient. Why do we differentiate? To have, because the curve does not give me gradient directly. So I need to differentiate the equation of the curve to get dy upon dx. When dy upon dx is there, so what do we do next? When dy upon dx is there, we know that dy upon dx is basically your equation of the gradient for the point on the curve. So what do? We make sure that we substitute value of x to get gradient for tangent on that point. That means the equation of gradient for the point on the curve comes to dy upon dx. When we have the equation of the gradient, what do? We substitute value of x to get gradient for the tangent on that particular point. Now, that means what next can happen once we have the gradient? So that means once we have the gradient, once we get the gradient, we can have equation of tangent or equation of normal. Your equation of normal means perpendicular to tangent. That means your equation of tangent will be the normal equation from the point, and equation of normal will be the perpendicular line from that particular point on the tangent, which means all the green lines are tangent here. So if I want to represent normal, your normal will create a 90 degree. Your normal will create a 90 degree. Your normal will create a 90 degree on each tangent. So when it creates 90 degrees, so we can always say that the equation of normal can also come while reciprocating the gradient with negative sign. But to find equation of tangent, what do you need? We need to have the point of x and y. That means what do we need? Equation. We need coordinate of x and y for tangent as well as for the normal. For tangent as well as for the normal. And where do we get the coordinate from? The coordinate that we get will come from equation of the curve or equation of the line. When we substitute value of x in equation, we get what? We get coordinate. And coordinate of what? Coordinate x and y of equation of tangent or equation of normal. So that means if the equation of tangent and normal will be equal to m1 into m2 is equal to -1, the gradient will always be reciprocal with negative sign. The gradient will always be reciprocal to negative sign. So at the point of understanding this, you should be knowing that the entire setup of differentiation is because of finding the equation of tangent, finding the equation of normal, or finding the value of x. But initially what you need to understand is that why do you differentiate? You differentiate because you do not have gradient of the curve. To find the gradient on that particular curve, you differentiate to get dy upon dx. That dy upon dx will become what? That dy upon dx will basically become your equation of gradient. When we substitute x, we get gradient. With the help of that gradient, we can always find equation of tangent, equation of normal. But this equation of normal comes through what? X and y. When x and y comes from where? Your y equation. And y equation can be equation of line, equation of the curve. When you substitute the value of x in the equation, you get the coordinates. And when the coordinates are there, eventually you get what? Equation of the tangent, equation of the normal. Using what? Using y minus y1 m x minus x1. That means equation of the line, equation of the line form, which will eventually be y is equal to mx plus c. So the main concern here is that you need to find out values from very different direction. You need to find out values from the curve as well. You will need to find out value from the, you need to find out value from the equation of gradient as well, because equation of gradient will give you the gradient when you use x. Similarly, d2y upon dx square will tell me the nature of the curve. It will tell me the nature of the curve. And what will be the nature of the curve? That means if d2y upon dx square is greater than 0, we get minimum. And how do we know that? How do we draw minimum? Your minimum will be that there is a curve and there is a minimum point. There is a minimum point. Similarly, if d2y upon dx square is greater than 0, that means this should be what? Maximum. This should be maximum. And that means you will have what? This is your x-axis, this is your y-axis. This becomes your maximum point. Maximum point. With the help of this minimum and maximum point, you need to understand that your dy upon dx is always 0 in the minimum, or dy upon dx is 0 in the maximum. That means the gradient and minimum and maximum are 0. That means the minimum and maximum gradient will be 0. And why does that happen? Because your minimum point is basically parallel to x-axis. So normally the x-axis gradient is 0. So parallel to x-axis gradient, tangent will also be 0. Similarly, your x-axis has gradient 0. So the line at the maximum, because that is your tangent, maximum line will also have 0. So in the other word, that dy upon dx will be 0 when we have maximum or we have minimum. And most importantly, dy upon dx will be used when the question says it has a stationary point or find the stationary point. Basically, stationary point reflects the maximum and the minimum value, the gradient, and that gradient will be 0. So we have, up till now, we have only discussed what can be asked by the examiner in the differentiation. So let's discuss more about it, because unless this information is not clear, you will not be able to attempt the question, because you will not be able to know what to do in the question. So what could be asked by the examiner? Examiner can tell you to differentiate y. So to differentiate y, this will be dy upon dx. Then the examiner can tell you differentiate dy upon dx. So from dy upon dx, you will get d2y upon dx square. The examiner the examiner can ask you, find, the examiner can ask you to find or calculate gradient. So in this case, substitute value of x in dy upon dx to have gradient. Substitute value of x in dy upon dx to have gradient. Then the examiner can also ask you nature. For that, differentiate dy upon dx to have d2y upon dx square. If d2y upon dx square is greater than 0, it will be your minimum. If d2y upon dx square is less than 0, it is your maximum. The examiner can ask you to find out equation of tangent. So if in the question equation of curve is given, differentiate to get dy upon dx, substitute value of x to get gradient. Then you can always have to find coordinate. For coordinate, substitute x in equation of curve. Substitute x in equation of curve. Using dy upon dx gradient and coordinate in y minus y1 mx minus x1, you will get equation of tangent. Then the examiner can always ask you to find equation of normal. The examiner can ask you to find equation of normal. And to find equation of normal, the process of differentiation will be same. That means y is to be differentiated to get dy upon dx. This is for what? Equation of normal. Y is to be differentiated to get dy upon dx. You will get gradient equation. Substitute value of x. substitute value of x to get gradient. Then reciprocal with negative sign, you get gradient for normal, which is perpendicular line, a curve. This is your tangent, and this becomes your perpendicular normal line. So when you reciprocal with negative sign, gradient for normal will be there. Gradient of normal. Then again, this gradient of normal and coordinate of x and y will be used in y minus y1 mx minus x1 to have equation of normal. The examiner can always ask you to show or to find the value of the stationary point. This is 6, 7. Find the value of stationary point. To find the value of the stationary point, you will always have to equate dy upon dx equal to 0, and then solve. You'll always have to equate dy upon dx equal to 0 and then solve to have that value of the stationary point, which means maximum or minimum point. Maximum or minimum point. The other important thing that you should be knowing is the formulas of topic. Mensuration of O levels, because cuboid surface area, which is 2 into LB plus 2 into LH plus 2 into BH is used. Volume of cuboid is also used. That is L into B into H. Similarly, the examiner can always ask you circle, which is pi r square, semicircle, which is pi r square upon 2, area that I'm talking about. Then rectangle is area length into breadth. So the formulas, there are a lot of more formulas in mensuration, so you need to go through the mensuration topic as well from the O level, because these formulas are important. So this was from lecture number 1, that defines what is differentiation and what are you required to do in the topic. We have still not discussed the rules of differentiation. We have not still used the rules of differentiation. Inshallah, we'll be covering that up in lecture number 2.